Hello, this is day one of the unit circle. We are going to start pulling the things that we have done for the past several lessons and connecting them. A reference angle is a acute angle that is formed between the n side of an angle and the x-axis, and it is always positive. So when you're drawing your angle, you can see here, these are the different quadrants, just like you would have in a coordinate plane. So in the first quadrant, if this is the terminus or the end of the angle and the reference angle would be the same. Over here in the second quadrant, this is the angle from here. Again, we always start the positive side of the x-axis, and you're going here. So then the reference angle, again, is from here, the end, to the x-axis, because it's always from the n side to the x-axis, so it would be here. From here, for the angle falls in the third quadrant, the reference angle is here, from the end to the x-axis. It falls in the fourth quadrant. The reference angle is here. So the reference angle is really important in the unit circle, and you have to find it before you can evaluate the trig function. All right, so we talked about that. The standard, the green was the standard angle, the angle that they gave you, and then the red was the reference angle. So let's draw some angles and then show you how to find that. So the first one that we have is 5 pi over 8. Now, if you're not comfortable with this, you can always change a radian to your degrees. And we do that by multiplying by 180 over pi. That will simplify out your pi's. Okay, so that's 112.5 degrees. So I'm going to draw just a simple x-axis. Yes, you're going to want to draw a diagram. It really helps to understand if you're adding, if you're subtracting, or if it's just the angle itself. So if we're over here, we know 112.5. It's positive, so we're going this direction. And it's going to fall in the second quadrant because it's between 90 and 180. So it's going to be about, it doesn't have to be accurate here. So this is 112.5. So the reference angle, again, is from the x-axis to that side, so it's here. So how much is that? So we know that this is 180, so if I subtract 180 minus 112.5, that will give us this angle here, which is our reference angle. Right. So this is going to be 67.5 degrees, and that's our reference angle. So it says draw each angle and then find the reference angle. All right, so this one, I'm going to draw a quick sketch. I know it's more than 360. I also know it's negative, so we're going that direction, clockwise. So I'm going to subtract from 360. Okay. So that's going to be negative 140. Now, because we're going in this direction, so this is the full angle. This is negative 90 here. This is negative 180. So I know it's going to fall somewhere in here someplace. Okay. So this full thing is negative 500. from here to here, just that after the first full rotation, this part is 140. Now again, since it's 180 here, you're going to subtract 140 from 180, and that's going to give me 40 degrees. And you're going to say, Ms. Mendoza, why isn't it negative? Because I said the reference angle is always positive. So here it's just 40. Okay. So we've talked a little bit about the unit circle, and we're still at the beginning stages. So we're going to learn to create it. We've done parts of the special right triangles, 3 different ones, and we're creating it so we can find these values without a calculator. So some of them are really difficult to figure out on a calculator. And it's a good practice to hone all your skills. So we had done this in class, and this is a summary of what we did. Now you can see that 30, if you change it to radians, is pi over 6. Each of the reference, and then that means each reference angle is 30. So this angle here, let's see what I did. Okay, see 150? So this is a terminal angle here. It's 150. You can see it's converted in radians. Notice that the denominator is 6 with a reference of 30. So even this angle over here, 210, it's 7 pi over 6. And when you go over here, the reference angle is still 30. The last one, 330, which is all the way around. The reference angle would be here, which is still, right? So 360 minus 330 is 30. Notice that when you convert it to radians, the denominator is still 6. So anytime the angles in radians has a denominator of 6, the reference angle is going to be 30, and that's going to help us. The next triangle we did was 45. And if you convert that to radians, it's pi over 4. And so if we notice these angles, right, 135 ends with 4. 225, 5 pi over 4. Oops, I didn't write in the reference angles, but these are all 45. So here, 225, if you subtract it from 180, because this will be the reference angle, would be 45. If you go all the way around for 315, if you subtract that from 360, it would also be 45. Note that the denominators for each of the angles in radians is 4. The last one was 60-degree reference angle. So you can see in the first quadrant, the reference angle and the regular angle are equal. And this is pi over 3. And then you can see that all the denominators are 3 when you convert it to radians, and each of the reference angles are 60. And we also looked at the points and how they're related. Same numbers, but different signs depending on the quadrant. Actually, this one's a mistake. I'm going to add this one in here. This should be negative. Okay, negative, positive, positive, negative, positive, negative, negative, positive, negative. Let me double check. Angles are good. I mean, the points are good. Positive, positive, negative, positive, negative, negative, positive, negative. Okay, because we want to make sure everything is correct in your notes. All right, so putting things more together. So we're still not going to use the unit circle again. But how does everything that we did? So before we found the 6 trigonometric ratios given a point or sine of one ratio first, but now we're given the angle. Okay, so what I'm going to do is draw that angle. And we're looking for the reference angle. So we'll see how everything now works together. So I know it falls in the second quadrant because 120 is between 90 and 180. So 120 is here. So the reference angle here would be 60. Now I'm going to blow it up a little bit because I didn't make it big enough. All right, so here's 60. Here's 120. So knowing what we know, well, on the unit circle, when we get here, we know the radius is 1. We know that this is going to be the short leg. So this is -1/2. This over here is √3/2. Now, once we know that, we can find sine, cosine, and tangent. And it is of 120. I know you're going to say this is 60. We're just using the reference angle to actually find the values for 120. So let me put this in. Okay. So the sine is opposite over hypotenuse. So √3/2/1 is just going to be √3/2. Cosine is -1/2/1, so it's going to be -1/2. And tangent is going to be √3/2 over -1/2. Now, when you have that, I can divide the twos or multiply 2 to the top and the bottom, and that will simplify out. So I'm going to have -√3. I really needed more room. Okay, so cosecant, secant, and then cotangent. So we're doing the reciprocal, so that's 2 over √3. We do not like denominators, roots in the denominator, so this is going to be 2 √3/3. This is going to be, so you're doing the reciprocal of -1/2, so it's -2. Keep the signs, they're very important. And this one I'm going to go here, so it's going to be -1/√3, so that's going to be -√3/3. So that is for this one. Ugh, I use a lot of space. Okay, so for the next one, I know I'm going negative. Okay, and now this, it's 4. So automatically, I know it's a reference angle of 45 because the denominator is 4. But I'm not sure what quadrant it falls in. I know, but if you're not sure, you can convert it to degree. It's actually going to fall into the second quadrant. I'm going to change it to degrees just for those who need to see it, -225. So if we're going here, because it's negative, we're going this way. And it's -180 here, and this is going to be -270, and so it would fall in between. And it's a 45-degree angle. So drawing my angle, again, I know my reference angle is 1. This is, sorry, my radius is 1. So this is √2/2, -√2/2. Sine of -5π/4. Cosine -5π/4. Tangent -5π/4. All right, so cosine is opposite over hypotenuse, which is 1. Cosine is adjacent, just here, over 1. Tangent is this over this. Now, when they're the same, right, so you're going to have √2/2, -√2/2. So that's going to equal -1. All right, getting very squishy. Cosecant of -5π/4, which, and then secant is over here, -5π/4, and then tangent, sorry, cotangent, -5π/4. I'm going to do this bottom one because the reciprocal of -1 is just -1. All right, the reciprocal of √2/2 is 2/√2. When you simplify it, you're going to do 2. It gets a little complicated. So it's 2√2/2, which simplifies to √2. So, and I know that will happen the same for this one. So it's going to be just -√2. And that'll happen every time when you have √2. When you take the reciprocal, it's going to be √2. All right. So do you see, this is a lot of stuff that we've done. Converting from radians to degrees, drawing an angle, finding the reference angle, and knowing the 6 trigonometric functions and what they are. So that's a lot of what we've done, pulling it all together into one problem. All right, so here are practice on your own, 2 problems just like the ones that we did. Take your time, draw a picture first, then the reference angle, and then hypotenuse is 1, and then find the opposite side and the adjacent side. You can use your pieces of paper. It may help you with that. Okay, and don't forget to answer the EQ. Thanks for watching.